In part 3 of this section, we're going to work example 3. It says, find all points having a y-coordinate of -3, whose distance from the point 1, 2 is 13. And you read that and you think, okay, I have no idea what they're talking about. What do they mean? Well, in order to get a handle on it, let's draw a picture. Pictures are always good. So they give me a point. My point is 1, 2. There's the given point at 1, 2. Now, we know that there is another point that has a y-coordinate of -3. So y-coordinate of -3 is somewhere down here. So anything along this line would have a y-coordinate of -3. I'm just going to pick a generic point over here, and I'm going to call that point x, -3. In other words, I don't know how far over it is, but I know how far down it is. It's at -3. And what that really means, what they're telling me is that the distance between these two, that distance is 13 units. So they've given me the distance, they gave me a point, and now we have the coordinates of a second point. We can plug into the distance formula. And that's what we're going to do. It's been a while since we wrote it, so we're going to write it one more time, again, to help you memorize it. So that distance is equal to the square root of x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. Okay, that distance is 13. That's going to be equal to the square root of x2 is just the single x, minus x1, which is 1, quantity squared, plus y2, which is a -3, minus y1 of 2, quantity squared. And there it is. Now all we need to do is solve this equation for x, which is why we spent the first couple of weeks solving equations. So we need to do this kind of stuff. Now there are longer ways and shorter ways to do this. I'm going to do it the most efficient way. So let's clean this up first. So 13 is going to be equal to the square root of x minus 1, quantity squared. Notice I'm not foiling that out. I'm going to leave it alone for now. -3 minus 2 is a -5, and a -5 squared is a positive 25. Let's get rid of the radical. So let's square both sides. Again, what I'm trying to do is get that x isolated. That's going to give me 169 is equal to the quantity x minus 1 squared plus the 25. Now we can go ahead and move that 25 over. And I knew I was going to remember. That's going to give me 144 is equal to the quantity x minus 1 squared. Well, now we're solving for x still. So let's go ahead and square root both sides. That'll give us x minus 1 on the right side. So let's take care of the squaring. Left side, because we are solving and we took the square root, we're going to add in that plus or minus 12. And you're thinking, wait a minute, doesn't that mean I have two answers? Well, yes, it does mean we have two answers. One of the answers is sitting over here, but it should make sense that there's another point over here that's same distance. So that's where the two answers are going to come from. We'll go ahead and move the 1. When I move the 1 over, I'm going to put it in front of the plus or minus so I can add and subtract to get my two solutions. So x is equal to 1 plus or minus 12. So x is going to be 1 plus 12, which is 13, or x is equal to 1 minus 12, which is a -11. Okay, so let's make sure we understand what the solution to the problem is. One point is sitting over here at 13, -3. The other point is sitting over here at a -11, -3. So we have two answers, and those are the coordinates of the point. So they're asking us to find all points having a y-coordinate of -3, whose distance from the point 1, 2 is 13. So two answers. That comes from that plus or minus over here. So let's walk through what we did to solve it again. Once we've written the formula, we cleaned up inside the radical. We squared both sides to eliminate the radical. We moved the constant over to get the quantity squared by itself, which was the variable, and we square rooted it and finally solved from there. So quite a few steps. But if you follow those same steps, you'll be okay. Here, last example from section 2.1 actually deals with the midpoint formula. So a few minutes ago, we had a picture on the board that looked something like this. So we had a point here, which we called x1 and y1. And we had a point up here, which we called x2 and y1. And what we're looking for this time is the point that is halfway between them. It's in the middle of those 2 points. So what we're saying is that this little distance and this little distance are the same. And that point right there is a capital M for midpoint. Well, if you're trying to find the middle of something and you have the two ends, like trying to find the middle exam score, right? Or the average exam score. So what we're really going to do is find the average. So to find the midpoint, we're going to use x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Notice that we are adding them and then dividing by 2 because we're going to average them. And that's the midpoint. It is a point, so don't forget the parentheses around it to indicate that it's a point. Okay, in example 4, we're being asked to find the midpoint of the line segment joining the points P1, which is at 2, negative 3, and P2, which is at 4, 2. So here are 2 points. Let's find the one that's halfway between the two of them. So I'll label again just to get us back into that practice. So x1, y1, x2, y2. So then the midpoint is equal to 2 plus 4, that's the sum of the x's, divided by 2, and the sum of the y's, which is negative 3 plus 2, divided by 2. So 2 plus 4 is going to give me 6 over 2. Negative 3 plus 2 is going to give me a negative 1 over 2. Reduce any fractions. Don't take it to a decimal unless it's an application problem. So 6 over 2 gives me 3, comma, negative 1/2. There's the middle point between the two given points. And that's the information that's in section 2.1.